Okie dokie. Welcome everyone. Thank you for joining us today. Welcome to the Dark Sky Project. My name's Olive. I'm one of the astronomy guides here. And welcome to International Observe the Moon Night. We're going to start today with our lovely public talk introducing us to the moon and also some of the other moons in the solar system as well. We would have then been going on to observe the moon with the telescopes, but as you may have noticed, the weather is not on our side today. But instead, what we're going to do after is we're still going to head into the Brashear telescope, which is the one outside, and we can kind of see how it works. You can hear a bit about it if you'd like to as well. If at any point today during the talk you guys need to leave, you are welcome to just head back out the door that you came in. If you then want to come back, reception can let you back in, no stress. The talk is going to be anywhere between half an hour to 45 minutes. And if you have any questions at any point, please just let me know. It's a little bit dark, so I may not fully see any hands. Oh no! It's been breaking on me today, so just ignore it. But yes, if you've got any questions, please just let me know. Or save them till the end and we can hang around and chat for a bit. But our International Observe the Moon Night here at the Dark Sky Project is kicking off World Space Week for us. Because it is from the 4th of the 10th of October every year, we do World Space Week. All around the world it's celebrated. And here we are doing our International Observe the Moon Night talk. We're doing another public talk on Monday, centered more around the moon, some of the stories, but also some of the fun facts with the moon as well. It's going to be a bilingual talk, which will be really fun. And then on Friday, if you guys are still here, we're doing our pub quiz hosted out in the diner. Drink specials, lots of fun, so bring your A game if you are coming. But let's get started with learning about our moon, because there's a lot to talk about. And the first thing we can talk about is how the moon came to be. And it started pretty much at the start of our solar system, 4.5 billion years ago. And there was a lot going on in the solar system. It was a very chaotic place. It wasn't as settled in kind of our neat little disks that we see it is now. There was stuff flying everywhere. So we believe that our moon was born out of destruction. We think that we had a kind of Mars-sized object called Theia that came crashing towards Earth. They got pulled together by gravity, caused a big impact, and then we got a disk of debris spreading around, which eventually coalesced to make our lovely moon orbiting around us. This is our leading theory so far. Obviously, something from 4.5 billion years ago is quite hard to prove. But we have got a bit of evidence from our Apollo missions when NASA sent people to the moon, because they brought back about 400 kilograms of lunar samples. And from this, we analyzed kind of what the moon was made of, and we kind of worked out that when the moon was born, we think it was really hot. It was kind of all liquidy and magma rather than the solid rock that it is today. And this kind of showed us that the start of the moon's life must have been quite violent. There must have been something to heat it up that much. And our only kind of guess at that is there was some kind of huge impact. The other kind of theories that we have that the moon was just born alongside the Earth, and theories where the moon is captured by the Earth, so it's an asteroid and it comes in and then kind of gets stuck going around our Earth. We don't really think they're as possible because they wouldn't have given us all this heat to make our moon magma at the start. So this is our leading theory. We're probably just going to keep gathering more and more evidence to go along with it. So now we know where the moon came from. Let's learn a few facts about it. Let's learn how to observe it a bit better and understand why it looks like it does in the night sky. So I've picked 4 of my favorites here. We're going to delve into them a little bit more. Number 1 is that the moon is located 380,000 kilometers away. Second, we always see the same side of the moon. So we have a near side and we have a far side. This left one here is what we get to see in our night sky. This is the other side. Down here, we have the phase of the moon determines when we see it in the night sky. So the shape, the size of the moon will determine when we see the moon rise. If it's going to rise with the sun in the morning, if it's going to rise and be there all night, this changes depending on how big the moon is. And then finally, the moon actually looks the same size as the sun in the sky. So let's talk about the distance. And here we can see that the exact distance to the moon, 384,400 kilometers away. And what that means is the light that we're seeing from the moon has taken 2.5 seconds to reach us here on Earth. And the moon isn't making its own light. It's not like a big light bulb in the sky like the sun is. It's reflecting sunlight. And so once the light hits it from the sun and it starts reflecting back, that's those 2.5 seconds to reach our eyes. In comparison, we have Mars, a lot further away, one of our next closest planets, about 6 to 44 minutes its light takes to get to us. And the International Space Station here, it is in a low Earth orbit. That's only 400 kilometers away. So those are the numbers behind it. The fun facts are that between us and the moon, we could fit 30 Earths side by side. Quite a big distance. Even cooler, this is our little Earth this side. This is all of the other planets, and this is our little moon. All of our planets in the solar system can line up next to each other and fit between us and our moon. Coincidence, definitely, but still very cool. So that is our distance to the moon. We always see the same side of the moon because the moon is what we call tidally locked. It's close enough to Earth that we have this tidal locking, so we always see this near side of the moon. We have taken photos and humans have been to see the other side of the moon before, but from here on Earth, you only ever see the near side. And this is because tidal locking is basically that the moon and the Earth have been companions for so long that the Earth has slowed down the moon's orbit. So the moon takes 28 days to do one full orbit around our Earth. It also takes 28 days, exact same time, to spin once on its axis. So do one moon day actually takes 28 days. And we can see from this little animation here that our smiley face is always facing the moon. So the moon is still turning as it's orbiting, and that's why we've got it facing. This is what other untidally locked planets and moons do. They kind of get to see every single side of the moon in one full rotation. We always have the one facing towards us. And you can actually see here that from the near side and the far side, there's quite a few differences. Our near side has lots of these darker patches. We call them lunar maria. And this is because it's the Latin word for seas, maria is, because originally these were thought to be kind of oceans on the moon. When we couldn't really zoom in and see what was actually there, these darker parts were thought to be oceans. And they were kind of, but in the sense of they were big kind of oceans and pools of lava. The moon used to be volcanically active. Some would come up through volcanoes and cracks, and eventually the moon cooled and all this lava did as well, giving us these really dark and flat plains on the moon. And because they are so flat, this is where we decide to do our lunar landings. Like the Apollo missions, one of them went to the Sea of Tranquility, which is one of these little patches. But when we look at the far side, we see that there's a lot more craters, there's lots of these little tiny holes, but there's really not any of these darker patches. And that, we think, is because of Earth's pull on the moon. So because our near side is the side that's being pulled towards Earth a little bit, it means that when the moon was volcanically active, all that lava kind of got pulled towards the Earth more than the other way around. There's seats over here, guys, if you don't want to sit on the floor. But yeah, so the lava inside the moon kind of got pulled more towards our side. So that's why we have lots of these lunar maria. Hi guys, welcome. And then less on the other side of the moon. So that is our tidal locking. That is why we always see the same side of the moon. The next thing we can talk about are the phases of the moon, because this is more to do with how we observe the moon. This is what we see in the night sky. We've got a little diagram here. We're going to talk through it. And we've just got to remember that the moon reflects light, reflects sunlight. So when we get a new moon, This is when we don't see the moon at all day, all night. And that is because the side of the moon that's being illuminated is on the opposite side to the Earth. Because we've got sun, moon, Earth. We don't see the side that's being illuminated. This is our near side. This is the side we can't see. And that also means that the moon rises at the same time as the sun. It's in the same place in the sky, so it rises with the sun, but it's invisible to us. It's there all day, we just can't see it. Then the moon is going to move over the next couple of days further away from the sun over here, and we get a waxing crescent. Waxing for the moon just means it's getting bigger and bigger. And what happens here is, from our point of view down here, we can see a little bit of our side illuminated just down here. So we get this beautiful crescent shape. It's going to keep going, and it's going to get over to first quarter, where half of our near side and half of the far side is being illuminated. And this means that we get the moon rising a couple of hours after the sun. Because it's moved this far away, we see it later in the daytime. We then get to a waxing gibbous, where we're seeing a lot more of our side illuminated, also rising probably in the afternoon by now. Eventually, we get to full moon 14 days later than new moon. This is when our full side and near side is being fully illuminated. So we're seeing this whole side that's being illuminated, so we get our beautiful full moon. And because it's directly opposite the sun, it is rising exactly at the opposite side to the sun. So as the sun is setting, the moon is rising. As then the moon sets, the sun rises. Then for the next 14 days, the moon is going to move closer back to over here by the sun. It's going to get smaller and smaller because we're seeing less of it illuminated again. And it's going to get later and later into the night that it starts rising. So by the time we're here at third quarter, we don't get it in the evening kind of nighttime sky. We're getting it maybe at like midnight or something rising. So we've got one fact left. We've got the moon looks the same size as the sun. And this is because, it's actually complete coincidence, but it is because the sun is 400 times further away from Earth than the moon is. And it's also 400 times bigger than the moon. So those numbers add up to make it look the exact same in the night sky. And this gives us eclipses. So it's lucky coincidence we get our lovely eclipses, and we're actually not going to get them forever, because our moon is slowly moving away from Earth, about 4 centimeters a year. But in our big distances of space, this isn't actually going to affect us for about 1 million years. So we're not going to lose eclipses anytime soon, don't worry. But how they work is that we get 2 different types of eclipses, a solar eclipse and a lunar eclipse, and it depends on what order our sun, moon, and Earth are all lined up in. So our solar eclipses, which are a little bit more rare, they happen when the sun lines up with the moon in the middle and Earth on this side. And what it means is, if you're stood in this little tiny patch here on Earth, you are going to see the moon completely blocking out the sun. So the moon's shadow is on you. So if we get a total eclipse, we then get darkness in the daytime for a little bit. We can get partial eclipses as well, where the moon is kind of slightly off, but it's still blocking some of the sun. Get some pretty views with that as well. But yeah, solar eclipses, more rare because you have to be on the daytime side and you have to be in that tiny little shadow to be able to see them. Our next solar eclipse here in New Zealand is going to be in July 2028. And you can always check the internet if you're going off somewhere else, because you may have one coming a little bit sooner or later. It's very different depending on where you are in the world. And our solar eclipses, are only going to happen at new moon, because we need the sun and the moon to be together in the daytime sky, that time when we don't see the moon at all. Our lunar eclipses, a little bit less rare, because we get the sun lining up with the Earth and then the moon over here. And there's a lot more shadow over here for it to fit into. So we get total eclipses a lot more. And it doesn't quite work the same. The moon doesn't get completely blocked out and disappear in the night sky. Instead, it turns a lot more faint and dimmer, but it becomes really red. You guys may have heard of it being called a blood moon. And this is because the sunlight is coming towards Earth. It's getting blocked by most of it, but a little bit of it is going to get skimmed across the top. And instead of just carrying on, it skims and actually gets bent inwards to reach the moon. And this is just the red light though. So the blues and the purples and the other colors, they're going to get absorbed by the atmosphere just up here. But a little bit of the red light is going to actually keep going and get bent inwards to illuminate our moon red. This is how sunsets work as well. That time of night, the red light is getting bent a lot more, so we're getting to see our little red sunsets. And yeah, lunar eclipses. The next one here in New Zealand is March 2026, so in a couple of months. But we only see them at full moon, so when the sun and the moon are on the opposite sides of the sky. So why do they not just happen every month? Because it sounds easy, right? We just need the three things to line up. But unfortunately, our moon has decided to have a little tilt. It is on a 5-degree angle to the Earth, so when it goes round, it kind of goes down and back up a little bit. This means that we need them all to perfectly line up at the exact right time to get our eclipses. So unfortunately, no eclipse every month. Okie dokie. So, 4 really cool facts, but a lot of information. So does anyone have any questions? Do we need anything clarifying? Just want to know stuff. Awesome. I'm taking that as a good sign. Okay, let me know if you do, don't worry. But what we can do next is talk about the rest of our solar system, because our moon isn't the only moon. And there's lots out there. And the ones I've picked for us to talk about, there's just a couple, are ones that are really interesting to us here on Earth at the moment. Because with World Space Week, we have a theme every year. And the World Space Week theme this year is living in space. And that is mainly to do with how humans may live in space, technological advancements and science that's getting us there, celebrating all of that. But I'm going to put my own little twist on it. And we're going to talk about how not just humans could live out there, but how maybe other life could live out there as well. Because the moons that we're talking about have been classed as potentially habitable. It's a really specific phrase, I know, but it's because we're not saying we've found life there. We haven't found life there, and we don't think humans could live there. But there's some building blocks that we consider might help us with life that we found on these moons. Mainly to do with some kind of water, because here on Earth, basically everything needs water to survive. It's one of our really big building blocks for life. So if we find water anywhere else, we get really excited. So that's basically what's happened here. We've got lots of moons with potential water. But before we look at those exact moons, let's learn actually how many moons there are in our solar system. And there's over 300, just going to warn you. But our 2 inner rocky planets, Mercury and Venus, closest to the sun, actually have no moons. We then move on to our other 2 rocky planets. Earth, we know, has 1. Mars, the red planet, has 2. We call them Phobos and Deimos. They are named after the ancient Greeks' pain and panic. If you've seen them from Hercules, those pain and panics. And we think these ones were captured asteroids. So they're little kind of funky shapes, they're not round. So we think maybe an asteroid got a little bit too close to Mars at some point, and Mars just basically scooped it up and kept it going around it. So that's what we think has happened with Mars. We then move on to our gas giants, our biggest planets that definitely like to collect their moons. We have Jupiter with 95 and Saturn 274. There's lots going on there. Some of them really big, some of them bigger than the planet of Mercury, some of them tiny, some of them the size of a sports arena or a football field. And then we finally have our ice giants of Uranus and Neptune, 28 and 16 moons. And I'm sure you guys have noticed big difference between those numbers. And we're not 100% sure why, but one of the main theories is that the bigger planets, they used up lots of material to make themselves back in the early start of the solar system, but there was also still lots of material left over around there. And so they were able to kind of create the moons going around them. Whereas it was a lot more dense in the inner solar system where these guys were being made. So they managed to all kind of collect up all their material, and there wasn't really any left over to form moons alongside them. So we think these two not being formed at the same time as their planets, these ones more likely to be. So let's talk about our first potential habitable moon. And this one is Enceladus. This is an icy moon that orbits around Saturn. And it is the sixth biggest planet of Saturn, and it is the brightest object in our solar system. It reflects basically 100% of the sunlight that hits it. And it was first discovered in 1789. And the first time we kind of got interested in it with potential habitability was by the Voyager missions. These were two spacecrafts, Voyager 1 and 2, sent out in the 1970s, and their mission is basically to get as far away from us as possible. They're doing a good job so far. They're still going. But on their way out of the solar system, both of them wanted to study some other planets so we could learn more about them. And they both went past Saturn and then some of its moons as well. And what happened when we looked at Enceladus over here, we saw that it was quite a smooth planet, quite a smooth surface. Quite young is what we call it as well. So we can see that there's lots of craters, these little dots. These are made by impacts, so little rocks hitting the moon. But if it was a really old surface, there'd be loads more of these. But what has happened is the moon has its surface has shifted and changed. So it's kind of erased those older markings of craters to make a lot more smooth. And this is what happens when we have tectonic or geological activity. So like here on Earth, we have our tectonic plates on our crust that move and shift, and they create new mountains or get rid of mountains with earthquakes and stuff like that. And that is basically what we think is happening on Enceladus. So first interesting thing. And in 2005, we decided to send the Cassini spacecraft over to Saturn and some of its moons, with its mission just to learn as much as it could. And it flew by Enceladus 22 times. So we got 22 observations in. And when this happened, at first, it found all these cracks. So this is the South Polar region, and we can see lots of little cracks happening down here. And then it also kind of water vapor clouds hanging above those. Did more flybys, learned more, found out that these weren't just weird clouds, they were plumes. So from these cracks, this watery material was coming upwards and getting exploded into the area around Enceladus. And at the end of the Cassini mission, 2015, our final flyby of Enceladus, Cassini went through one of these plumes. It analyzed what it was made of, and we found organic molecules. When we talk about organic molecules, once again, it's one of those really specific phrases. We're not saying we've found little bacteria or little aliens. What we're saying is we've found nitrogen or carbon-based molecules, which are kind of the building blocks for all life as we know it so far. So if we find them, we get excited, but not too excited. So Cassini found these in these water vapory clouds, which means we quite like Enceladus. It's got a good chance to be a habitable place because we found it's got that young surface, and we found it's got those plumes of organic molecules. And what this is signaling to us with both of these together is that there's potentially underneath this icy crust a subsurface ocean, because that is where these plumes may be coming from. They need to be coming from somewhere, this water and vapor, so we think maybe these oceans. And we also found more out with the Cassini mission because it flew through Saturn's rings. And Enceladus lives in one of Saturn's rings, in the E-ring we call it. And measuring what the E-ring was made of, we found what we call silica nanograins. And we think these came from Enceladus, because those plumes we were talking about, they replenish the ring. They keep adding material into that E-ring. And these silica nanograins, don't worry, I don't really know what they are either. What I do know is that they are made when there is liquid water, there is rock, and there is temperatures over 90 degrees. On Earth, that means in hydrothermal vents, bottom of the ocean, where we think life may have started originally. So very exciting, we're finding these silica nanograins that we think are from Enceladus. So this gives us an idea that there are hydrothermal vents. Once again, scientists got very excited. Until this year, there was a specialized experiment, a little study, that looked into how we can make silica nanograins. And they simulated what the surface of Enceladus would look like. And they basically found that you could have silica nanograins form in that environment. Which means it was a bit of a caution. Caution to scientists to make sure we don't get too far ahead of ourselves, because we just assumed then there was hydrothermal vents. But what this has shown us is that these silica nanograins could have been made on the surface of Enceladus, or they could have been made inside in hydrothermal vents. We don't know which one, but we need to be careful not to just assume the exciting one. So that is everything for Enceladus. Anyone got any queries or questions? Awesome. Once again, taking it as a good sign. Let's move on to our next moon then. This is Titan. This is another moon of Saturn, discovered in 1655, and it is the biggest moon of Saturn. It's also the second biggest in the solar system. It is the only moon that we know of that has a dense, kind of substantial atmosphere, which basically means when we look at Titan, we can't see its surface. It's got this hazy atmosphere around it. And we first got interested in it, just like Enceladus, with our Voyager missions. They went to Titan at the same time they went to Enceladus, and they couldn't see the surface. They weren't equipped for that. But what they could do is kind of analyze a bit of that atmosphere. And we found methane and ethane, those kind of things, and some organic molecules as well in that atmosphere. If we add that and we add together that Titan, pretty cold, it's in the outer part of our solar system, there was some speculation that we could have liquid methane on the surface. But then we fast forward once again to the Cassini-Huygens mission. It's the same Cassini as Enceladus, but this time Cassini went to Titan and dropped off the Huygens space probe. So it went over Titan, it dropped, it parachuted Huygens down through the atmosphere onto the surface so we could learn even more about it. Cassini then carried on, did over 100 flybys, so we got loads of information on Titan. And we discovered a really cool thing, that we have a liquid cycle there. So here on Earth, we have a water cycle. We have our clouds, we have our rain, our rivers, our oceans and lakes. That also exists on Titan, but it's liquid methane, not liquid water. And means we wouldn't do very well with it. We need water, we don't need methane. But what's to say there's some kind of life out there that hasn't worked out how to rely on liquid methane instead of liquid water? So it's a very cool thing. It's the first time we found this kind of liquid cycle anywhere else. So that was our first indication that this might actually be a really cool moon. And then we watched from different flybys how the geology, the surface of Titan changed. Because it has mountains, it has those lakes. And so between flybys over the 13 years that Cassini was going around Titan, we saw the mountains and the lakes shift positions a little bit. This gives us indication of tectonic activity, that crust kind of moving again, meaning we had more proof for a subsurface ocean. Because you can't have this stuff kind of shifting. You can't have your tectonic activity, your surface shifting, if the whole moon is just solid rock. That just doesn't work. Like here on Earth, we have a core. We have liquid as our magma in the middle, and then we have the crust kind of floating on that. This is what we think is happening in Titan and also in Enceladus. You have a solid core, you have some kind of liquid ocean. We're betting it's salt water. And then you have the crust, this ice, floating on top, doing those kind of changes and tectonic activity. And the final characteristic we kind of have that we like about Titan is what we found in the Voyager as well, was that its atmosphere is actually mainly nitrogen, which is the same as Earth. Our atmosphere is actually mainly nitrogen as well. So yay, another kind of similarity. Titan is a good bet for our potential habitability. So good that the Dragonfly, one of NASA's new spacecrafts, is going there in 2028. Yeah, getting launched in 2028, and it's what we call a rotorcraft. It's basically this kind of little space drone that's going to get parachuted once again down onto Titan's surface. But instead of just having to stay by the landing site, this one can explore a lot more of the moon. It's one of the kind of newer models, I guess, that NASA's working on. I think it's our first rotorcraft potentially going up into space. So keep your eyes out on that. Maybe we'll learn a little bit more about Titan. So we're going to head away from Saturn now. Go for it. Just out that way, guys. Have a good night. We're moving on from Saturn now. We're going over to Jupiter, the king of the planets. If we remember, 95 moons. Europa, fourth biggest moon. It's a little bit smaller than our own moon. Discovered in 1610 by Galileo. And it was first indicated that it may be interesting to us with the Galileo mission spacecraft 1996. And what Galileo did, the spacecraft, was have a look and measure the magnetic field of Jupiter and its moons like Europa. Because Jupiter, being so big, has a really big magnetic field, really strong. So strong, in fact, that it washes over its moons. And what happens is that when it washes over its moons like Europa, it creates a new magnetic field, a temporary one that surrounds Europa. And this wouldn't happen if we just had a solid moon. We need a subsurface ocean, we think, to get this new mini magnetic field. This is because when you have a magnetic field in physics, if it goes over something conductive, something that can have electricity, it can induce an electric current. And water, especially salt water, really good at this. So if we have a saltwater ocean, it can induce this electric field, which then can make its own little magnetic field for a little while. So a couple of steps, but we get from the magnetic field of Jupiter using this subsurface ocean to create a little temporary magnetic field around Europa. So that's what we did. We found that little magnetic field, and that signaled a subsurface saltwater ocean underneath the icy crust of Europa. And we want to learn a little bit more about this. So the Europa Clipper, which was launched last year, is heading on its way to Europa and going to be there in 2031. It's going to fly by the moon 49 times. Unfortunately, it can't sit there and just circle around it because it's in Jupiter's magnetic field, which is stupidly strong, going to cause lots of radiation damage to the spacecraft. So it comes in by the moon, and then it shoots out for a little while, have a bit of a rest, then comes back again, then shoots out, just so it doesn't damage itself too much. Our goal for Europa Clipper is to find out as much as we can about it and see if it is potentially habitable. We want to look at its surface, its ocean, all of that stuff. We then also have JUICE, launched in 2023, getting there in 2031 as well. This mission is going to look at Jupiter and its icy moons, so including Europa, and it's going to look more at the chemical composition, see if we can find out a little bit more if there's any organic molecules, any interesting stuff like that there. And actually, we don't just have a subsurface ocean, we've got more water plumes. Because in 2013 and 2016, they pointed the Hubble Space Telescope at Europa and thought we saw some of these little plumes. So that water vapor and stuff being squirted out from the planet. And then we re-looked at the Galileo missions. And we actually think that one of the flybys, there were 11 of them, we think Galileo actually went through one of these plumes. So we've got building evidence for water plumes as well as a saltwater ocean. Awesome. So that is Europa. We can then keep going and we can find Ganymede. This is another moon of Jupiter and it's its biggest one. It's also the biggest one in the solar system. the only moon big enough to have its own magnetic field, which causes some really cool stuff to happen. Once again, discovered at the same time, 1610, and then the Galileo mission made it interesting to us. The same way as Europa, it looked at that magnetic field, found out that there was an induced one, found out, hopefully, saltwater ocean. But the other cool thing about Ganymede is its magnetic field. It has its own magnetic field that's there all the time. And here on Earth, our magnetic field does something fun for us. It gives us aurora, northern and southern lights. So that means that Ganymede gets aurora too. And aurora are linked to those magnetic fields. So the Hubble Space Telescope was looking at Ganymede and watching these aurora change. Because when the magnetic field of Jupiter changes, causes that magnetic field to get changed at Ganymede as well. With that subsurface ocean, those induced currents, just like Europa. And that changes how the aurora looks on Ganymede. So they basically went aurora hunting on a whole different moon to find out that it had an ocean underneath its surface. A lot going on, lots of science. So once again, we're going to have JUICE going there to look at it alongside Europa, find out more about that ocean, those magnetic fields, those aurora, hoping we're going to learn some more as well. So yeah, subsurface ocean, aurora. Aurora doesn't signal any kind of potential habitability. It's just cool. Anyone have any questions on any of those moons? It's a lot of information. I'm fully aware, so don't worry if you don't remember it all. Go for it.
So you said the mission's going to reach in 2031.
Mm-hmm.
Do we get the data immediately?
Ooh, so NASA kind of can choose when it releases it. I think because it's a public kind of service, does have to release it within a certain amount of time, maybe like a year or something. But what they'll do is they'll do press releases, they'll show off the images. They like showing off what they found. So 2031, they will definitely keep us updated. Some of the more like nitty gritty, really in-depth science, they might not release until they're fully confident on it, but we'll get to see all those awesome photos and everything they find, and it'll all just come out. So yeah, hopefully keep your eyes out in 2021, 2031. We'll definitely find out some stuff. Go for it.
Is the Europa mission doing anything other than just looking at Europa?
I don't think so. I think it is just fully focused on Europa, and then we've got JUICE going to look at those other moons as well. Awesome. So our final moon, we're nearly there. We're looking at Triton. Different to Titan, this is the biggest moon of Neptune, and one of our outer icy planets, and it was actually only discovered 17 days after Neptune itself. We first found it interesting with the Voyager mission because that is actually the only mission that has gone to Triton. So this is a really mysterious moon for us. We don't know too much, and only 40% of the surface has actually been observed. And what Voyager 2 did was it had a good look at Triton, and we found ice volcanoes, basically similar to those water plumes. And what would happen was methane and nitrogen get squirted out, and then they would cool because this is one of the coldest objects in our solar system, and it would then come down to the surface as snow. So we have snow on Triton. And after we saw this, we were like, okay, this must just be from the sun. Because at the time, Triton was here, Voyager was here, the sun was beaming this way. So we thought these kind of plumes and volcanoes were getting heated by the sun, and that's why they were able to squirt out their material. But actually, since we found plumes on Enceladus and Europa, we've reconsidered that actually these ice volcanoes and plumes may be coming from somewhere inside. They're not just heated from the sun. We think, once again, there's a theme here, potential subsurface ocean. So stuff is coming from inside the planet again. And originally this was a really tricky thing for us to understand because Triton's really far out from the sun. It's really cold one of our coldest objects. So why would the water inside not all just be ice? Why would the whole moon not just be ice? And this is because we think the core, the rocky core in the center, is big enough to have radioactive decay. So there's bits of material in that over time are decaying, giving out radiation, which is then heating the ice, the would-be ice around it, meaning that it can maintain this liquid ocean in there. So another planet where we have a core, liquid ocean, icy crust. But yeah, I'm excited to learn more about Triton. I like that it's kind of mysterious for us. But unfortunately, NASA, ESA, no one really has any future missions going to Neptune yet, but hopefully one day. So, we've learned a lot. We've talked about our moon. We've learned kind of how the phases work and eclipses, all that kind of stuff. And then we went even further and we went a little bit sciencey, I apologize, but we've talked about the different moons in our solar system. Potential habitability, so keep your eyes out for all of that news, all of those missions in 2031, 2028. See if we learn anything new about these potential other worlds. That is everything I have to ramble at you guys today. Thank you so much for joining me. As I mentioned at the start, unfortunately the moon does not want to be seen today. It's being shy. So we won't be able to use the telescopes to observe. But if you would like to come and learn a bit more about the Brashear telescope, we'll be heading in there now. If you just want to have a chat with some of us guides as well, you're more than welcome to. And don't forget, we have our other moon talk, our bilingual moon talk on Monday, English and Mandarin. And then on Friday, we have our space-themed pub quiz in the diner. So make sure to come, bring your A game, as I said, if you want to join that. I'm going to be hanging around, guys. So please come and talk to me if you want to. If not, have an amazing rest of your night. And I hope you get to see the moon at some point.